Hello, everyone. Thank you for tuning in to this edition of Talking Tech. My name is Ron Haskell. I'm the Director of Communication for the Office of Information Technology, and it is my pleasure to fill in today as your host. We have an interactive and informative program put together for you this afternoon that will happen in two parts. In just a moment, we'll have an opportunity to hear from Jay Paluch, who's the Operation Triage Group Director. In order to perform world-class healthcare benefits, VA employees and veterans need the systems that power their technology to work and work well. Jay will highlight the latest advancements at VA OIT, focusing on its relentless pursuit of achieving what we call our 4 nines. This means guaranteeing exceptional stability and significantly minimizing outages to just a mere 52 minutes per year. That means we shoot for our systems to be up 99.99% of the time, hence 4 nines. If we don't get to all the questions by the end of this show, that's what we'll get to. There'll be no need to worry. We'll make sure to roll those up and provide answers to the ones that we're not able to. So we'll have a Q&A after we go through with Jay. And with that, I'd like to look forward to now that we know what we're going to look forward to over the next hour, let's get started. Jay, thanks for joining us on Talking Tech today. My first question to you is, what the heck is the Operation Triage Group Director? What do you guys do? It sounds like a neat job.
It is probably one of the best jobs that someone can have. And I've got the honor and privilege to be the leader for our operations triage group, which is primarily made up of site reliability engineers and problem managers. And unlike those site reliability engineering roles that we see out in the public today, we're a little different. We're not necessarily centric and focused on one system, but our engineers are actually involved enterprise-wide. So we are involved in application work, in our operations areas, and in our infrastructure. So we have an opportunity to work in all those areas with our primary responsibility to help solve some of our biggest technology problems, and do that through ways of understanding and recognizes where we have performance and resiliency issues, recognizing that through a lot of the performance data that we collect, and look for ways through automation to improve that, as well as ways in process and how we improve that as well too.
So we talked about a lot of processes and improvements, and I talked at the top about sort of why we do it. Could you lay out a little more specifically, like what are 4 nines? That's a goal that we set, correct? And then why is that so important to both staff and to veterans?
Yeah. So you mentioned at the top of it too. So 4 nines, I think it's like 52 minutes a year that we set ourselves to have the max amount of downtime. So that's 99.99%. And what that really means is in the number side of it is we're looking to say that 99.99% of the time, our system or actually our systems are up and available for our users to use and to support our veterans, as well as for our veterans to use. That's not just the math, though. It's also a culture. And if you think about it, it's not a matter of just saying that we're at 99.99%, but how do we actually attain that? And it's a way of thinking. It's the way that we approach all of our most critical systems. The VA has well over 1,000 systems that we work with. We have of that a subset that are the most critical. And in many cases, those are supportive of all those other systems that we have. They're dependencies, as we often refer to them. So if you think about this, 99.99% of the time, that's 52 minutes. If we were just to knock that down and just say it's 99.9% of the time, that knocks it down to 525 minutes. That means we can have 525 minutes a year for that system to not be available. So if anyone speaks to something and says 99%, now we're talking about weeks of time that it could be down. That's pretty significant, and we don't want to ever go in that direction. The idea here is to push our culture and the way that we think to always be available. So think about it, 99.99% of the time is our system trying to do its best to be available all the time for all of our veterans.
So you talk about it being open 99.9% of the time. That is interesting when you take a 10th or 100th off, how that grows to a completely different goal when you frame it that way. Mr. DelBene talks about a delightful end user experience. That's our overarching goal, foundationally. So having the systems up is obviously important to that. What sort of impact are we talking about, having these systems up? What does this mean to veterans and to staff?
Um, I liken it to picking up an old analog phone. When you pick that up, you're expecting to hear the dial tone every single time. When an end user uses one of the VA systems, their expectation should be, as we delight them, that it's up and it's available, that I can actually open up my laptop or my desktop and I can see a screen. I can actually then take and authenticate and log into a system. I can actually then do the transactions that I'm supposed to do to be able to support a veteran, whether that be in one of our hospitals or that be for benefits. It's something that we want to continually strive for. So when someone uses that, it's available to them. But in addition to that, it's not just availability. This is also around usability. So when we say we want to delight our users, we want to make sure that they have the equipment that they need, that it works the first time they actually start to use it. It's not difficult to install or start to open up an application. All those things are taken into consideration. So not just availability, it's also usability. It's how well do I navigate through that system? And when we look at this, we're not just looking at that 4 nines in the realm of it's up and it's available, but is it also capable of doing what the users expect it to? And we refer to that, and it's known as our service level objectives. Are we able to actually measure what it is that's important to our users as well? And how well is that hitting it? If we say that every time I log in, I want to be able to log into the system every time I get into it, well, that's how we start to structure things around that concept and that culture of 99.99%.
Interesting. So, having worked at VA for a long time, there are thousands of systems,
Yes.
hundreds and thousands. Do we prioritize that at all? Are there like specific systems that we prioritize for the 99.99?
We recently went through a program to recognize and focus on what we consider to be our most critical systems. So we refer to that as our critical 100. It is something that has been in the making, in the history of it probably goes back a year and a half, when we recognized that we did have some key systems that we wanted to make sure were always up, always available. And we did a lot of research, and we started out with what we referred to as our fragile 15. And that's where we started to recognize, of those, how can we actually make them less fragile, more available for our end users? And we took a cross section of system owners across OIT, and we sat down and started to discuss the idea of fragility, and also, more importantly, the idea of critical. And what we immediately found out is what one group thought was critical, another group thought differently. And it caused us pause to come back and say, how do we get to a single value of criticality? And we developed a methodology that was formulaic in nature that gave us the ability to rack and stack each of those systems. From that, we then brought that to our senior leadership. And we said, look, we have this list, and it basically recognizes all of our systems in some way. And it's objectively put together through this formulaic model. And we recognize that there might have been some tweaks that we as regular users of the system, we as owners of it know are probably making that even more critical than it is. So think about this. If I want to make sure that I have a system that processes benefits claims for our veterans, I need to make sure that I actually have an infrastructure that supports it. So that's probably on a higher scale more important. I need to make sure that I can actually log into that system. I need to make sure that the network is available to me. So we had to do some subjective levels to that scoring as well. And as we did that, we came up with this list we refer to as our critical 100. We broke that into two parts. We broke it into what we refer to as our bedrock systems. Those are what we consider to be our most critical of critical. And those are the ones that have the highest degree of dependencies, as I mentioned before. So those that refer to authentication, those that refer to our cloud environment, those that refer to our infrastructure and our network. Those became our bedrock systems, or those that we use primarily to process and adjudicate our benefits claims, or those that we use in our hospitals to support our veterans that are in the hospitals for healthcare. The remainder of the list became the rest of our critical systems, and we try and keep it capped around 100. I think right now we're probably at about, I think it's 94, 95 systems. That leaves us a little bit of headroom as other systems come in. And all of a sudden we recognize, because of law or policy from Congress, this is something that's all, all of a sudden became very important. We want to make sure that we've got room to be able to support those as well.
I know the Bedrock systems, Fred Flintstone, huge fan, from the town of Bedrock. Moving on. We talk about, we sort of monitor these systems and we get a lot of questions. We're seeing this in the background, so please keep submitting, our folks watching on LinkedIn and YouTube. Can you describe how, like, there's a lot that goes into redundancy and failover mechanisms. So if something goes down, we're not crashing a whole system and we can continue to operate and do the work that we need to do for healthcare and benefits.
So I want to, when I think of failover and redundancy, some people try think of it in different ways. I want to kind of give the analogy that if you're driving on the road in your car and you get a flat, if you have a spare tire, you've got some level of redundancy, you've got absolutely a great level of failover. You still have to stop the car, you still have to get out, you still have to change tire to continue to go. You have a failover to it. But at the same time, you're stopped and your destination takes longer to get to. In the idea of redundancy, well, if you've got a car that has run flat tires, you can continue to move forward to get to your destination so you don't stop. The ideas are very similar in the fields of redundancy and failover, and not just at the VA, but wherever we are. We look to our most critical systems to ensure that we have that level of redundancy in there. And it's not just a matter of having the redundancy, but it's also a matter of how we're testing it, which is on a regular recurring basis, ensuring that when we need it, and in most cases we may need that, it's in place. And not only is it in place, but we have resources. Our staff is clear on what they need to do, and they're well practiced and written processed in order to make sure that when this event occurs and they need to fail over, because we have that redundancy built in, they're capable to do that, and it's a quick and easy process for them to do it. So again, too, that goes back to creating that environment where we ensure that we're getting closer, that culture of 4 nines, creating that greater level of resiliency for our systems.
So we had a great question that's come in while we were sitting here that I think sort of aligns with this. You talk about preparation and sort of looking at it. Yeah. Are there things that we do to prepare for unexpected events like natural disasters, cyber attacks, a mistake or human error or anything like that?
Yeah. There are so many things that the VA does. We don't sit here and wait for something to happen. There's a lot of work and practice that goes into everything we do, knowing full well that with the number of systems that we have, with the miles and miles and miles of cable that we have, with the number of people that are involved, the opportunity for a defect is always there. And the more components we have, the higher that opportunity is for a failure. So it's important for us to make sure that we're in place and we know what we need to do. A lot of things we do are around tabletop exercises. We do that for natural disasters. We do that for many of the systems that we have, where we actually do kind of like a drill so through our tabletop exercises for a system that fails. We have a command center down in Austin where we're actually going to be doing those live drills with people at our command center, bringing in everyone to sit there and watch, review, and then provide feedback on what we can do to make that better in the future. That's one thing. The other thing we do is we have daily calls with our CIO every morning at 8 o'clock, where we go through every one of our system outages that we had on the previous day. And it's an opportunity for those that own those systems to have a conversation with our CIO, as well as hundreds of others that are on these calls, to say, here was the problem that we had, here's what we found out was a problem, and here's what we're doing to recognize and fix that. Now, we don't end there. On a monthly basis, we go through all of those that hit our most critical, those bedrock systems and our critical systems. For those, we actually have a follow-up, and we refer to as our OpStat. And in our OpStat, we basically step down through any of the outages that we had, those that we might have covered on that morning call, and we take it one step further. We go through and we not only recognize, again, too, here's what the problem was, But also, here are some of the things that we found out about it. Here are some of the things that we fixed to make sure that that doesn't occur again. So it's never just one thing in that front. And again, too, we also track that. We have an outstanding team from a major incident management group that sit and they actually pull all of our calls together. We've referred to as our high priority incidents or our critical priority incidents, or HPIs and CPIs. This is the team that actually gets on board and pulls all of the right resources together so we can actually attack this as a group. We'll bring our SREs, we'll bring our system engineers on the call, we'll bring our system owners as well as our customers. And all of us will work together to find out what the problem is, what we need to do to get our users back up and running as quick as possible, or what we refer to as our time to repair. And then we also hang around to make sure that we look to see what are we going to do to resolve it. So in many cases, repair might be different than resolution. Repair gets us back up and running. Resolution makes sure that we've got everything in place. So if that were to happen again, we're covered for it. Now, in addition to that, we also have a team of engineers that are sitting 7 by 24. I mentioned that command center, our enterprise command center located in Austin. We have a team of resources that sit there 24/7 with the responsibility of watching all of our monitoring, all the automation that we have in place, and the monitors of all of our key critical systems. Well over 500, more than 50% of our systems right now have that level of monitoring on it, where we've got eyes on glass 24 hours a day, with those resources looking for and recognizing where we see changes in system behavior, where we might say that we've set these limits on system performance. And if it goes below that, or if it goes above it and exceeds what we expect it to be for capacity, for instance, that sets off the alarm bells. Then our event management team then starts to work with our major incidents team, as well as some of our end users, to determine how big this impact is. Then they'll stand up one of those calls. So as you can see, it happens immediately that we actually start to get engaged. It continues on through the event itself. We recognize the problem after it's occurred. We review that problem. We do retrospectives on that. We do after action reports as well as root cause analysis. And we track those through our problem management organization to make sure that we're tracking each one of those changes we need to make, and that they've been done, and that they've been tested, and that they've been incorporated. All that goes into play even before we get to that monthly review. And then again, too, those constant tabletop exercises that we do to make sure that we're prepared for any kind of event that would come up. Far more prepared than it would be if we were to just wait for the incident or the action to happen.
So it seems like there's a lot of pre-planning that goes into it.
Yeah.
There's a lot of sort of reflection and how to lessons learned out of all that. And then there's a lot of monitoring, of course, too. One question that I know we get a lot as it becomes more and more prominent, it's a current event everywhere you go, especially in the tech world, you hear about it. AI. Are we using AI at all, or what's the future of AI and sort of monitoring some of these systems to maybe identify, a problem or a trend, an issue as it arises?
So the answer is yes. There are activities that we know. So as we go back and let me kind of help a little bit here. When we go back and look at those incidents that have occurred in the past, and we use our folks from OTG and other areas to pull together that analysis, so the analytics side of things, and we recognize there is a regularity to this type of an event, and there's a regularity to how we answer that event. What do we do when that happens? How do we respond to it? How do we stand up a call? And then, in fact, the actions that we take once we recognize what the problem is. If we pull all that together, we start to recognize some level of recurrence in that, or the same actions occurring. We could use things like artificial intelligence to recognize that pattern again and do a couple of things for us. In an AI ops world, we would have that automatically go through, and if it's recycle a server, or if it's recycle a router or another device, we could automatically go through and do that. Or we could actually have it bring to one of our event management engineers, those folks at 24/7 eyes on glass, to say, we've seen this type of thing before 100 times. And in every one of those cases, 99% of the time, we do the following. would you want to continue to do that? And yes or no. So putting some level of manual or human intervention in there. So both of those are opportunities that we're working through, even as we speak today, and getting closer and closer to being able to launch things like that, so we can start to do those things around artificial intelligence, around our response, and around our ability to see a more resilient system and help us create greater levels of 4 nines. Think about that. If I'm using my systems to recognize those common problems quickly, I can actually make sure that that system stays up better or longer. Or when it reboots, I'm not bringing that system down for 30 minutes or an hour to try and figure out what's wrong with it. I'm moving forward knowing that this is the most common thing it is. I can actually get that back up and running faster.
So this question sort of came in on the side too. And you talk about bedrock systems, and if we're using AI and getting better and better at it. Is there such a thing as 5 nines for specific systems or things that we want to do to is the goal eventually to take it up another notch?
We could, but I think that actually starts to get into another area and a little beyond technology. So the answer is, could we get to 5 nines? Sure. That means you basically have a system that never fails. It's always up. It's always available. And let's face it, back to my original analogy, even your phone lines, at some point in time, an analog phone line fails. So it could happen. We could do that. But let's consider what the cost of something that might be. To get to 5 nines, and I think that's mere seconds a year of downtime, that then means we would have to create and build and spend a significant amount of the people's money to go and do that. Where instead we could actually use those funds to create greater resilience around the 4 9 space and continue to build out on that culture. We could do a lot more with 4 9s and looking to get there. And in fact, I would say even so much as to say, let's look at some of those systems that are sitting at 2 9s. And instead of spending the money to build out 5 9s, we use that to bring them up to 3 9s or 4 9s themselves.
Fascinating. Yeah, and when you frame it out of an hour a year versus hundreds, an hour a year is tolerable, right? That's a doable thing. All right. So Jay, we got 8 minutes left.
Sure.
We got a handful of questions in. Appreciate everyone that's submitting. Keep them coming in. If we can, Allie and the team, if we can pull some of the ones that we have and put them up on the screen, and we'll just go through and do a quick Q&A, Jay.
Sure.
So the first one is, how is VA OIT monitoring its systems to identify potential issues before they become full-blown outages?
Yeah, so there's a lot of that's a great question. There are a lot of things that we do. And as I said before, one of those areas is the AI, but through the extensive monitoring that we do, we could set normal thresholds for many of the performance behaviors of our systems. In many cases, what we'll do is set more conservative ones. So say, real simple, if we're looking at something such as CPU utilization, we might say that 95% CPU utilization might be fair. We might actually say, let's knock that down to 90, so we know ahead of time and we can actually get engineers involved saying that's an abnormal behavior. We also have tools that recognize that this system would normally run at, say, 80% utilization. And if we start to see a 1 or 2 level standard deviation beyond that, let's make sure that we're getting people involved to understand and recognize why. So yeah, there's a lot of things from all of our system owners, as well as from a lot of our monitoring that happens through the Enterprise Command Center and through the SREs, putting automation in place to actually catch things like that. So we are recognizing that. So in many cases, that's a lot of things that if it is in place, we're recognizing that already today.
Great. So next question came in. And we talked about this a little bit, especially on the technical side, but practically, what impact does achieving the 4 9s have on support for VA IT users, including staff, contractors, veterans?
Right off the bat, productivity, right? If my systems are up and running, and remember two pieces of up and running. So it is up and running. And then secondly, it is doing what we expect it to do. So that's that service level agreement side of things. If it's doing both of those, we have delighted users that are using systems that they find are capable of supporting the work that we do for our veterans. We become very, very productive when our systems are up and running. If we think about it, If a system goes down, it might only be down in some cases for 5 or 10 minutes. But what does that mean for people that are actually in the process in case, let's say, of adjudicating a claim and they lost their place or all the work that they put together, all the evidence that they've collected? Now they need to go back and build that case again. How much time is lost on the back end? How much time does it now take for everyone to come back online and log back in? They might have said, well, I'm going to go over and do this paperwork or training on this side. They're going to finish training. Well, that's lost productivity that they might have on doing the other work that they had. So all the things that we do to make sure that it's up and running, it clearly goes right back to productivity. It clearly goes back to what we're doing in our primary goal to support our veterans.
Okay, next up. This one I might have asked out of order when we had it, but you talked about natural disasters, cyber attacks, human errors. Anything else that outside of tabletop exercises?
Yeah. So again, too, the tabletops help us prepare for it. But the other pieces too is we learn all the time. For every event that we have, every incident that we have, there's a process that we go through to collect information. It's our problem management process. So we look to do what's referred to as a root cause analysis on what happened. And in many cases, it's not necessarily just a problem with a failure in a system. It could have been the fact that we changed something. And in the process of changing it, we forgot to do something. So human error. Or we changed the wrong thing. Or somebody followed the process incorrectly. There's so many different things that could cause a system failure. And we learn from every one of those. We'll go through that process, our problem management process, to recognize what that is through our root cause analysis. And then we'll go through and correct it. But not just correct it, but then verify that we did. And then also make sure that that's something that's part of our continued, our standard operating procedures going forward. If someone, in fact, made a change and they fat fingered something or they put it perhaps, in the wrong partition or directory, is there a way for us to have someone verify that? So like through a parallel effort, there's verification to that. That might just be a very simple step that we've put in the past that actually helps us ensure that that doesn't happen again. So whether it's human error, whether it's a natural disaster, every natural disaster, we're learning what could we have done better to respond faster. In many cases, we have a lot of early detection because of just weather, and we put things in place. We know that we will put a lot of our external devices in place. We'll put additional housing in place or something else to make sure that things are ready for when that occurs. And if it doesn't, we're just much more well prepared in the event that it did.
Nice dress rehearsal, if you will.
Yeah.
All right, a couple more minutes. What else do we have, guys? This is a great question. I like this one when I saw it come in. Does every VA system have redundancy and failover mechanisms? I don't know if we want to say out the ones that don't, but do we build it redundancy and failover pretty much everywhere we can?
I would say yes to that. There's probably, when we say systems, that's where it really gets kind of tough. If we think about it, most of our systems aren't just one person working on one laptop. It's a shared service or it's a shared application across, in many cases, tens of thousands of people. In those cases where we have larger scale, oh, you bet, yeah, there's 100% redundancy built into those. Where we have some of the smaller systems, we may not have full redundancy for every component, but if we think about it, our network, our infrastructure, our ability to sign into those systems, our cloud service providers, they've got a great deal of redundancy built in to make sure that if anything were to happen, other than perhaps maybe that core system, there's the capability to have that resiliency or that reliability that it will stay up and running. So there might be some cases where redundancy on that one piece of code or that one application doesn't have a failover location. But normally what we'll find out with that is it's not something that is key critical or one of those bedrock systems that we have tens of thousands of people, or that has urgency, within our emergency room, or for our doctors or for our devices. We wouldn't see any failure points like that don't have some significant amount of redundancy.
Okay, and we're just about 1 minute, so we'll take the last question. Again, thank you to everyone that has submitted. We had a ton of questions that came in, and we'll make sure we get to these in a blog afterwards. But if we can put up the last one here. So Jay, can you provide an example when a redundancy or a failover mechanism is used in VA OIT and the mission continued and we continued to deliver healthcare and benefits?
Oh yeah, absolutely. This is where my counterparts within our infrastructure network operations team will probably start laughing. But we have a not one way for our applications to traverse through our network, through our extra global network. We have actually 4 different gateways. If we have seen a system failure on one of them, what that actually means is anyone who may have been logged in, anyone who tries to log in that might normally route that way, might not be able to. Through the redundancy that we have in our system, we have 3 other ways to get in. And what that means is they'd be routed to one of those. And that's some of the great work that engineering team does to make sure that they're recognizing when something like that happens, we're able to do that. And that's, again, too, not just internal to us, but that's also to all of our external providers. If we think of all of the voice data providers that we have, all the incoming lines that we have across our services, our facilities, and the ability for us to be able to quickly pair over to one of our partner networks. The redundancy that's built in, even within our phone network, is incredible. That ensures that we can actually make sure if one carrier fails, the backup carrier is available to us. So yeah, I can't even specifically cite one example because we know that this happens on a regular basis. And it happens to the point that our users kind of still see that whole idea, that dial tone. This happens in the background. They don't even realize it.
Yeah, I've been the communication director here for just 6 weeks. And the amount of effort and work that goes into ensuring that I've taken for granted, really, that when I turn on my systems that they work. And same thing in the hospitals and all that. And so the work that goes into it is really incredible. Can't thank you enough for coming on and talking about it and sort of laying that out, that I think the more people realize the work and the effort and the thought process that goes into this, they'd be really amazed. So Jay, thank you so much.
Ron, thank you.
Yeah. That's going to conclude our program for today. Appreciate everyone that tuned in. I really appreciate everyone that submitted questions. The questions that we did not get to, we'll go ahead and wrap up and put into a blog that we'll put out on 4.9s. If you're interested in more information on 4.9s, we talked about the delightful end user experience and a lot of the other different things that we're doing at VA and OIT. Go to digital.va.gov. And you can always RSVP and join this program again to find out more interesting topics. So thank you again, everyone. Have a wonderful day and be well.